Okay, so in today's video, we're only going to have one video, but there will be 4 examples as part of that video. I'm going to solve some simultaneous equations. My hope is that we're building on something you already kind of are quite familiar with. This is kind of a refresher and showing you a few of the trickier little things that you need to remember. So I'm going to solve this first set. I like to label my equations before I start, 1 and 2. So we're doing equation 1 and equation 2. Remember, the first thing we need to do is make either the number of x's or the number of y's the same. Here we're going to make the number of x's the same. I'm going to go for the lowest common multiple. So if I times the top one by 4 and the bottom one by 5, that'll work. I'll show you an example where there's an easier lower common multiple in a second. So here we've got 20x plus 8y, and 19 times 4 is minus 76. And here we have 20x plus 15y, and 5 and 18 is minus 90. Relabel our equations 3 and 4. Now remember, this is a nice little trick. I'm going to take these equations away from each other to get rid of the 20x's. It's good to do the bigger number of y's here, take away the smaller number, because it keeps everything more positive than it is otherwise. So I'm going to do equation 4, take away equation 3. 20x, take away 20x is nothing. That's why we did all of this. 15y, take away 8y is 7y. Minus 90, take away minus 76. Taking away minus, so adding. So minus 90, add 76 is minus 14. And so y is minus 2. We want to put y equals minus 2 back in. You can put it back into either of our starting equations. I'm going to put it into equation 1. It's called equation 1 for no other good reason. And so we get 5x plus 2 times minus 2, because that's what y is, equals minus 19. So that leaves me with 5x minus 4 equals minus 19. Or 5x equals, add 4 to both sides, we get minus 15. And so x equals minus 3. Now it's always good when you get your answer to actually just write it out. So we've got x equals minus 3, y equals minus 2. There's our answer to this first pair of simultaneous equations. Now, second pair, very similar, but as I kind of alluded to, we have this, sorry, got the paper stuck. We have this slight shortcut we can take at the beginning. So there's equation 1, there's equation 2. We could times the first equation by 8 and the second equation by 6, but there is a more efficient strategy. The more efficient strategy is to come in here and times the first one by 3. Sorry, first one by 4 and second one by 3, because the lowest common multiple or the lowest thing in the 8 and the 6 times table is 24. So this is just a bit of a shortcut. We get 24x and 24x by doing that, and so we can take these away and they'll disappear. So we've got 16y equals minus 20, and 9y equals minus 6. Relabel equation 3, equation 4. Again, I want to keep the y's positive, so this time I'm going to do equation 3, take away equation 4. That gives us no x's. 16 take away 9 is 7y's. Minus 20 minus minus 6. So it's like minus 20. Adding 6 is minus 14. And so y equals minus 2. That was not intentional. That was the same as the first question. That is just by chance. So now we're going to put y equals minus 2 into, and we'll put it back into equation 2 this time, just for variety. So we end up with 8x plus 3 times minus 2 equals minus 2. That means 8x minus 6 equals minus 2. So 8x equals 4. Now be careful with this very last step. It's amazing how many people get this wrong. We're dividing both sides by 8. So x is not equal to 2. 4 divided by 8 is a half. Please don't make that mistake. It's such a classic, but such a silly little mistake as well. Again, write out our answer when we finish. So x to the half, y equals minus 2. There's my finished answer. Okay, so moving on down. Now, this is a little bit of a reminder. Here I'm going to make my y's the same to show you something particular. You could make your x's the same and you wouldn't need to worry about this. But I do want to show you this, remind you about this. So we're going to do equation 1, lowest common multiple of 3 and 2 is 6. So equation 1 times 2, equation 2 times 3. I've drawn these a bit close together. So we're timesing that by 2, so we end up with 4x plus 6y equals 38. And this equation we get 18x minus 6y equals minus 27. Now, what we've got here is 6y's and 6y's, but this is a plus 6y, this is a minus 6y. If I was to do equation 3 take away equation 4, I would end up with 12y's, because taking away negatives is adding to 6y, 6y is 12. So instead, if my signs are different, I want to add my two equations together. Okay, so it's a key reminder. Signs the same, then you subtract your two equations. If the signs are different on the two things with the, here we've got 6y's and 6y's, if those two things have the same sign, we subtract. Different signs, we add. So here we're adding 18 add 4 is 22. And 38 add minus 27 is 11. So here x equals 11 over 22, or a half. And we're going to put x equals a half back in. Really doesn't matter which one you put it into. Let's put it into 1. So we've got 2 times a half plus 3y equals 19. That's 1 plus 3y equals 19. And so, taking 1 off both sides, 3y equals 18 and y equals 6. Again, we're going to write our answer out. X equals a half, y equals 6. Now, all the way through, everything you've done at National 5, everything we've just done just now, you might spot these equations are reasonably carefully chosen. Seem to always pretty much get halves or nice-ish numbers, but the truth about simultaneous equations is most sets of simultaneous equations, if you wrote a random set of simultaneous equations down, or if you're doing a kind of maths problem or physics problem, chances are if you write a set of simultaneous equations down, it's actually not going to be all that pretty as an answer. And I'm going to show you one of those, and there's some practice questions on this, because it's really important that you get used to not always getting nice answers. So here we've got a slightly fuzzy camera. Here we've got two equations times top one by 6. So we get 42x plus 30y equals 66. And we get 42x plus 14y equals, and 7/16 are 112. Equation 3, equation 4. Keep things positive, so I'm going to do this one, take away that one. So equation 4, take away equation 3. And doing that, 42 take away 42 is nothing. 14 take away minus 30 gives me 44. And 112 take away 66 gives me 46. So y equals 46 over 44. Now, please, please, please simplify if you can. That gives me 23 over 22. It's not going to be a beautiful answer, but at least it's simplified down as much as we can. And actually, that will help in the next little step where we need to put back in the denominator being smaller. It just makes life a bit easier. I'm going to put that back in. That's going to be some nasty fractions work, but let's just do it. So we've got 7x take away 5 times 23 over 22 equals 11. And take your time with this, don't rush through it, just take your time. 5 23s are 115 over 22 equals 11. So 7x equals 11, take away 115 over 22. Now, lovely maths to go on here. Probably your easiest thing to do here is make them both over 22, deal with it all, and we'll deal with the divide by 7 in a second. So timesing 11 times 22, yeah, that is still the best thing to do. 11 times 22 is 242. Take away 115 over 22. Doing that leaves us with 127 over 22. Remember, that's still equal to 7x. X, divide both sides by 7. So it's 127 over, and 722s are 154. Now, it'd be nice at the end here to cancel down a little bit. It's a matter of kind of spotting if we can. Now, actually, at this point, now maybe I should have checked, does this 127 divide by 7? And go from there. Now, you might have noticed a slight pause there in the video. That was because I realized I made a mistake, which was I took this to the other side and I should have added it. So apologies. You're probably screaming at your screen wondering why I couldn't solve an equation. Doing that gives us 357, over 22. Dividing by 7, we get 357 over 154. Now, as I said, you could have actually checked, does this divide by 7? And yes, it does. So this fraction can be simplified down to give 51 over this divided by 7 is 22. So actually, maybe worth checking when you do that divide by 7, does the top number divide by 7? Yes, it does, 51 times. It saves you a bit of work with your cancelling. So, finish off, let's write our answer. So we have x equals 51 over 22 and y equals 23 over 22. Now, I know this is a huge fractions workout, especially if you mess up your adding, but it's good experience. This is tough, but it uses the same techniques, but gives you a bit of an extension, a bit of a stretch to what you already probably have done, by making that number work just a little bit more difficult. Have a go, see how you get on. Certainly do the easier questions and stretch yourself if you can onto these ones with some fraction answers and see how you do with those.